Hello, I'm Rune. I'm a geologist at the Norwegian Offshore Directorate. And today I will tell you about the geology of cold seeps, explained by examples from the Barents Sea. So, what are cold seeps? Cold seeps are also known as hydrocarbon seeps, methane seeps, or oil and gas seeps. This is something we find all over the globe. On the map up to the right, you can see them in every continental shelf and on outside of every continent. And usually it's only a matter of how much you have explored the area to how much you actually have found. And in the bottom of the screen, you can see some examples of cold seeps. You have the pure methane seeps, which is gas bubbles coming out from the seafloor, often associated with distinct biological communities and microorganisms feeding and living on the methane seeps. You have carbonate crusts, which is also created in these environments. Then we have the mud volcanoes, which is quite interesting features where mud filled with fluids and gases come out at the seafloor, builds up mounds, looking like a volcano of mud. Then these cold seeps can also be associated with oil seeps. And on the image you can see quite heavy oil coming out at the seafloor, but it can also be very light oil, looking more or less like motor oil. This slide shows the processes involved in natural oil and gas seeps. In every geological basin around the globe, you will have the processes there going on as long as you have a source rock which generates hydrocarbons. So hydrocarbons are generated deep down, accumulate in some kind of reservoir, and then through cracks or faults, they eventually come out at the seafloor. Some places more than others, depending on the geological setting. Gas bubbles will rise quite fast through the water column, and if the water is not very deep, some of this methane can come into the atmosphere and there contribute as a greenhouse gas. In deep water areas, very little of the methane or other gases reaches the surface while it is dissolved in the water. Oil has a slower rising speed, but when it ends up at the sea surface, it forms these oil slicks, which can be kilometers long and are easily detectable from specific satellites if the conditions are right. The light components of the oil quickly evaporates into the atmosphere, while the heavy components fall down eventually to the sea bottom. And if you take a sample from the seafloor in an area with oil seeps, you can often find traces of the oil without needing to hit exactly at the seep spot if you don't know where it is. These processes can be constant or episodic, they can be rapid or slow, or visible or invisible, also depending on the setting and what fluxes we are talking about. This map shows you the known natural oil and gas seeps we know about in the Barents Sea. So far, the last couple of years, many thousands of natural gas seeps have been mapped in the Barents Sea. And you see on the map here, these red stars just schematically shows you the regions where most of the gas have been found, especially here in the north, east of the Svalbard archipelago. And there is also some oil seeps known, which are these green stars. And we also have a couple of mud volcanoes discovered in the southern part here. But in this area here called Hopenjupa, this area alone has more than 10,000 gas seeps have been discovered. And also using satellite data, especially in the northern part here, hundreds of potential oil seeps have been also discovered. And a study a couple of years ago measured methane levels in the water column along the whole margin here, several hundred of kilometers, lots of samples. All the black dots you see here are water samples in the water column. And they found out that the whole area has a methane plume anomaly much higher than the background values, indicating that there is seepage going on for a wide area here. These ROV videos show you some examples of the oil and gas seeps we have been down looking at. To the right, you see two very strong gas seeps, indicated by the red stars on the small map. They have not been measured or quantified, so we don't know how much actually is coming out here. But obviously it must be quite a lot. The sea depth in this area is a bit deep, more than 300 meters, so not much of it reaches the atmosphere. It's being consumed or dissolved in the water column. To the left, you can see oil seepage, these black droplets here coming out from the seafloor and rising much slower than the gas, which you can see to the right in the video. On the slide here, you can see an example of the one mud volcano, which was known in Norwegian territories since the 90s. It was the only mud volcano ever or registered in Norway, but it's a large one. It's more than 1 kilometer in diameter, and you can see the very rugged morphological features they have at the seafloor. And this is at around 1200 meters water depth, and in the middle you can see some different geophysical data. The bottom is a deep penetrating seismic line, in the middle a high resolution seismic line, and then at the top a sub-bottom profiler zooming in on the details just below the seafloor, where we can see this mud coming up here. And people have been measuring and been doing lots of studies here on the gas bubbles you can see here coming out, and also gas coming through the sediments. And they've measured and calculated that this mud volcano alone emits many hundred tons of methane every year. And last year there was a new mud volcano discovered in the Barents Sea on the continental shelf, around 380 meters water depth. And it was investigated based on the morphological feature of a crater or depression at the seafloor, which emitted lots of gas, which was visualized on this water column data here. And when going down with an ROV, we could see this mud coming out from a small gryphon here, which is part of a bigger mud volcano in the bottom of this crater. And on the seismic data, there is many indications of gas coming up here in a gas chimney with seismic bright spots here beside the chimney. And the oil seeps I mentioned, on this image you can see interpretations from satellite data. All of these small polygons here indicates oil slicks of various sizes, which can be natural oil seepage. Most of them most likely are, because there is not that much shipping and other activities going on here, so you have very little human pollution here, and the discovered pollution has already been removed from the map. And the two of these have been visited with ROVs to confirm and sample the oil. The zoom-ins here of this one in Hopenjupe, that's the area with the more than 10,000 gas seeps. And the other one is just outside of Svalbard, 10 kilometers from the coast. With you can see the scale here, big oil slicks which can be imaged once in a while. So these two are both quite constant, and when being in the area on board a ship, you can easily see the oil drops coming up and starting to form these oil slicks. When sampling the seafloor, you can get oil directly up from gravity cores. And you also saw the ROV video earlier of oil droplets coming out of the seafloor. That was from Hopenjupe. And this area, the Hopenjupe in the central Barents Sea, is, as I said, a massive oil and gas seepage area, which is actually on top of the largest geological structure in the Barents Sea, which we call the Centralbanken High. And in this area, the glaciers through the Quaternary have been eroding down into very old rocks here of Triassic age. And you can see the structure here, this big geological high, all the seismic bright spots here indicating gas in the sediments here. Lots of faulting where this gas can seep up and then come out of the seafloor, where you see these gas bubbles here. This is also where there is oil coming out. And on the bottom, you can see a water column line acquired through 30 minutes. And on this line, more than 500 of these gas seeps were counted. And this is to the bottom right, you can see an example of one of these. This is a composite of on a certain number of pings. But you can see these gas flares rising from the sea bottom around 300 meters all the way up to directly under the ship. Based on the data collected in this area on various research expeditions, researchers from the university in Tromsø, together with myself, last year published a paper where we argue that this area is actually one of the most active submarine methane release hotspots globally. And the reason why this is a hotspot is basically because of the glacial history in this petroleum basin, where the glaciers have been eroding away all the overburden, which in a normal basin acts as a buffer. So up to the right, you can see these red areas indicates other glaciated petroleum basins, which could also be hotspots like the Barents Sea, which are still not investigated. To sum it up, this figure shows you a bit about how this geological setting controls the seepage in this area. We have the source rock below, which are generating the hydrocarbons, oil and gas, which are migrating vertically up through mostly through faults. They come into reservoir layers and then start migrating laterally, indicated by the yellow arrows here. And they accumulate in all the structures you can see here, which are acts as traps, and where these layers either subcrop on top of, for example, the highs here, or at the edge of this smaller basin here, we see seepage. We see seepage where these structures or traps have the cap rock eroded, and also where they have faults going all the way through the structure up to the surface. From the trap itself, or the reservoir, it's only 100 or 200 meters, so very little overburden here, making it very easy for the gas to escape. And that is basically what I've shown you now, the setting in most of the gas heaps we have in the Barents Sea. So with that, I would like to thank you for the attention.